I'm Ariel from Edward R. Murrow High School, and I did a science project on using the peels of different fruits to create bioplastics, which are a type of environmental sustainable plastics. And I tested them to see their rate of biodegradability, which I measured by their weight loss. Specifically, I used the peels of fruits because they're organic waste products. For example, how many of you recently have thrown away a banana peel without knowing fully what it could be used for? So I took advantage of these peels from potato peels, banana peels, and cassava peels and turned them with a few other simple materials into bioplastics. So bioplastics are made from plant sources and polymers, and they're biodegradable and very sustainable, and this leads to the overarching question, how can we change the plastic industry to sustainably produce environmentally friendly bioplastics? And my goal was to create bioplastics from different sources of starch, which is a type of polymer, from banana peels, potato peels, and cassava peels, and test them to see how effective they are at biodegrading, which means decomposing without fragmenting into microplastics. Starch actually impacts the properties of the bioplastics as well. The starch granule size and the ratio of the glucose chains can impact how fast these biodegrade. So here is my steps to create the bioplastics. First, I had to peel the bananas, potatoes, and cassavas. Then I had to sieve them and boil them to obtain the starch, which I set it out to dry. Then I was able to mix it with glycerol, water, and vinegar to form plastics and put them in the oven. And then to test their biodegradability, I actually buried them in compostable containers for 4 days and measured the weight loss. So as you can see here, they all started off at 3 grams, and the banana peel-based bioplastic lost the most weight over the 4 days, followed by the potato peel and cassava peel. So this proved my hypothesis, which was originally that the banana peel-based bioplastic would lose the most weight because of the differences in the starch granule size and the ratio of amylose to amylopectin. I know those are big words, but those are basically the glucose chains in starch. There were some sources of error, so I used 2 plasticizers instead of 1, and the plastics also turned out a little hard and stiff. So they weren't like conventional petroleum-produced plastics, but they were a type of bioplastic, which is cool. This also leads to the question, how can we actually use this to better our environment right now? So considering that the banana peel starch-based bioplastic had the best qualities as a bioplastic since it biodegraded the fastest, this could potentially function on the market for, in the plastic industry as a replacement to petroleum-produced plastics. And we can even use it to create utensils or everyday food objects or really anything. And this opens up the possibilities that we can use food waste to create bioplastic, which I think is such a cool idea. So I encourage you guys to go out and see what types of environmentally friendly inventions you can make and inspire others to take advantage of items that instead of being wasted can actually be turned into stuff like plastic. So yeah.